Welcome to the 2021 Virtual Materials Research Society Spring Meeting. We are going to have a full week of live symposium sessions, keynote and award talks, a dynamic and exciting virtual exhibit, and much more. This is MRS TV. Welcome to the first day of the 2021 Virtual MRS Spring Meeting. We're glad you're joining us today. We will feature an interview with 2021 MRS President Sherry Kagan, who will talk about goals for the Society this year, as well as journey to the U.S. Army's Combat Capabilities Development Command Chemical Biological Center. But first, let's check out some highlights of today's events. Today is devoted to several of our important tutorial sessions, as well as dedicated time for you to meet with exhibitors. The technical symposia will start tomorrow, but you can start viewing the on-demand talks already. Just go to the Symposia pull-down on the meeting platform, select On-Demand Symposia to see the recorded talks. Add tutorial sessions to your agenda by going to the Symposia pull-down menu in the meeting platform and then selecting Symposia Tutorials. We also have one exhibitor workshop today. Get to know our exhibitors by finding the Exhibitor Workshop tag under the Special Events menu. MRS TV is brought to you virtually from the 2021 MRS Spring Meeting. You can find us on the meeting homepage via the Hub on the navigation menu and through the sessions during regularly scheduled breaks in the technical sessions. You'll also find us on MRS Meeting Scene blog, and by hitting the playlist button, you can check out extended versions of all of our content from award winners to research center visits. It's all on MRS TV. Joining us now is MRS 2021 President Sherry Kagan. Sherry, thanks so much for joining us today.
Well, thank you, Atria.
Well, when you were elected to be Vice President in 2020, we certainly couldn't have imagined what MRS and MRS meetings would have looked like now in 2021. How has the pandemic affected the Society?
Sure. I think the pandemic has affected obviously all of us. It has presented many challenges to the way we as a society and our members work. As a society, we aim to convene, collaborate, integrate, and advocate to advance materials excellence. Obviously, this has required us to temporarily, of course, hold our meetings as well as other activities of the society virtually. But as we navigate the challenges of the pandemic, appreciate the solutions enabled by science to address this pandemic, I certainly hope we all look forward to new opportunities that present themselves.
Obviously, there has been a tremendous impact on the MRS meetings. Do you think that the adaptations that the organization has had to make will have a long-term effect on the nature of MRS meetings, or maybe more broadly than just the meetings, will it affect how MRS engages with its members year-round?
While we all very much look forward to, again, meeting in person, I think the MRS now is looking at the opportunities that virtual platforms have enabled to expand our products and to support our members. Their interest and their careers in science. This year, MRS has increased the number of virtual webinars and workshops, and this meeting is giving our community a platform to convene. We are exploring new opportunities that virtually enable scientific exchange between our members more frequently, and that reaches out to allow greater inclusion of our materials research colleagues.
MRS has been studying ways to make its governance structure more effective. What can you tell us about this effort?
We have restructured the board committees really to focus on its responsibilities that are fiduciary or in developing and maintaining our policies and procedures as a society and in ensuring the function of the society. We also restructured our operating committees to be more effective to serve the society, to support emerging topics in materials research, our products of meetings and publication, our advocacy, and our career development activities to support our members.
This is the first year of the publications partnership with Springer Nature. What impact will this new partnership have on the MRS publications portfolio?
As you already indicated, the portfolio of MRS publications are now being published under a partnership and will be archived by Springer Nature. It's really an alliance that builds on the brands of both of our organizations to ensure technical excellence and dissemination of our materials publications.
And we know diversity remains a key goal for the Society. Tell us a little bit about the importance of diversity in scientific research, and how is MRS helping to advance diversity?
Yes, MRS brings together members from diverse disciplines and demographic groups, and certainly believes that diversity drives innovation, excellence, and new discoveries. We want to explore new ideas and to take actions to enable exchange and include all members of our diverse community. And again, we welcome suggestions from our membership.
Thank you so much for your time, Dr. Kagan. Enjoy the rest of the meeting.
Thanks again. And I just want to say I wish everyone the best and hope you enjoy the MRS Spring 2021 meeting.
Synthetic biology is changing the way we approach challenges in material science. At the U.S. Army's Combat Capabilities Development Command Chemical Biological Center, researchers are utilizing fundamental biotechnological discoveries to develop the advanced technologies of tomorrow.
We are at the cusp of a fourth industrial revolution, this bio-revolution, and the Department of Defense is eager to harness the value proposition that's being offered here.
Synthetic biology is something that for years has been around and been being developed especially for making new chemicals, but we're really just at the forefront of learning what we can really do to make new materials for a variety of different applications.
We've heightened biotechnology and material science to one of our top priority research areas so that we have the people and the apparatus to be able to really harness the value of biotechnology over the next several years for the benefit of the warfighter.
The U.S. Army's Chemical Biological Center is the premier lab in the world for combating chemical and biological threats. We really have the ability at the Chem Bio Center to span early fundamental research all the way through applied research and testing fielded materials, which is something that you just don't find anywhere else. BEAM stands for Biological Engineering for Applied Materials Solutions. Its main goal was really focused around how to use synthetic biology and biological engineering for making new and novel materials. When we started the BEAMS program, we had great material scientists, we had great biologists, we had great chemists, we had great engineers. But getting them all speaking the same language was something that was incredibly difficult. One thing that we did was we had a lecture series where we had our internal subject matter experts teach each other.
We brought experts on various aspects of material science and biology to share some of their knowledge. We also did a team-based activity where we got the scientists together to work in the lab and work on a hands-on problem.
There are a lot of people at the center with a lot of really diverse skills. Once you just sort of put the idea out there and allowed some people to interact with you, amazing stuff can really start to happen.
The Synthetic Biology for Military Environments program brought together Army, Air Force, and Navy scientists. We worked together on synthetic biology problems. Cell-free systems are an important synthetic biology platform. We're able to use all of the active components you find inside cells activated outside of the context of a membrane-bound organism.
With a lot of modern materials techniques, we've come up with ways of taking reactions that previously had to happen in a container in a laboratory and literally have them laid down on a simple piece of paper. We have some paper-based sensors that are effective against chemical warfare agents like sarin or VX, for biological hazards too, things like anthrax and ricin. The end result on the sensor is essentially the same, and it is a little spot that starts off one color and changes to a completely different color to indicate that that threat is present.
At the Chem Bio Center, not only do we make a lot of things in-house, but we work with a lot of external collaborators at universities as well as within industry. So what this allows us to do is take early fundamental research and then work with industrial partners to make them into real products that we can put into warfighters' hands.
The VOC-Kit is a little portable reader. We'd made these little tickets that had about 80 different spots of dye on it. This is way too complicated for somebody to read by eye, so we knew we needed a machine to read them. We probably worked with 3 different companies. One was the company that was working with the arrays for us, and one of them was making injection molds for us, and another one was integrating circuit boards for us.
One of the collaborators that we work with is the Massachusetts Institute of Technology. They have a very unique way for making novel carbon materials. We can incorporate in oxygen, nitrogen, sulfur groups in very specific spots and have them be able to interact with chemical threats in a way that we've developed. Within the ChemBio Center, not only do we have the ability to synthesize and make new materials, we have the ability to uniquely characterize these materials.
We use a number of different techniques for studying the chemical interactions on these new materials that we're developing. On an ultra-high vacuum chamber, we introduce that surface to chemical agent, chemical contaminants, pollutants that might be in the atmosphere, and we can use our IR spectroscopy at the same time as our mass spectrometry, and then we can see how the surface has changed using something like XPS. With the new chambers that we have, we can go all the way up to atmospheric pressure. This is really advantageous for the BEAMS program because some of these studies involve biological samples.
Prototyping, getting things into the hands of the warfighter and letting them break it is critical. That requires not milligrams of material, but kilograms of material. Here at Aberdeen Proving Grounds, we have the only pilot-scale biomanufacturing facility that exists within the Department of Defense. Over the next several years, we're going to conduct a multi-phase upgrade of that facility. We're going to first increase the capacity. We're at 1,500 liter fermentations now. We're going to move up to 5,000 liters. Advanced materials has become central to the way we are choosing and selecting and prioritizing what we manufacture in the facility.
At the ChemBio Center, you have a real opportunity to grow a career here. The projects that we work on are very riveting and things that we can see go from fundamental science right into real-world products.
The center values generalists because our mission changes as the need of the warfighter changes, so we're encouraged to continue to develop throughout our careers, take on new skills and try new challenges.
Getting to work with this high-end equipment and apply it to a real-world problem, and also a problem where we're talking about how to protect our soldiers, it really gives a lot of meaning to what you do when you come to work every day.
And that's all for our first episode of MRS TV. Make sure to join us tomorrow for more highlights from the second day of the virtual meeting, as well as a fascinating interview with MRS Outstanding Early Career Investigator Award winner, Dr. Hualin Sheen.